Good evening, everyone. A very happy 80th Independence Day to all of you. Namaste, and a very warm welcome to our respected guests, scientists, academicians, researchers, faculty members, coordinators, students, innovators, and technology enthusiasts joining us from across the country on this historic occasion. Today, as India celebrates its 80th Independence Day, we commemorate 8 decades of resilience, growth, and freedom while honoring the vision of an Atmanirbhar Bharat, a self reliant, strong, and technologically empowered nation. This landmark 80th Independence Day stands as a sacred reminder of the priceless sacrifices made by our freedom fighters and visionary leaders who dreamed of a sovereign India. It is our collective responsibility as young citizens and innovators to honor that legacy by driving our nation towards a complete technological self reliance. I'm Yogita Jadhav, student coordinator at KIYE Foundation, and it is my absolute pleasure and privilege to host today's special Independence Day edition S Talks Lecture 21. Before we begin, I kindly request everyone to introduce yourself in the chat box by mentioning your name, college, and a very happy 80th Independence Day greeting. It will be wonderful to see where everyone is joining us from today. It was truly inspiring to witness participants from every corner of India united by one common passion: science, innovation, research, and nation building. KIYE Foundation is a non-profit organization dedicated to inspiring young minds through science, technology, aerospace, defense, innovation, entrepreneurship, and leadership. The foundation was established by Mr. Naresh Indian with a vision to bridge the gap between academics and industry by connecting students with eminent scientists, defense experts, researchers, entrepreneurs, and professionals. Inspired by the vision of Bharat Ratna Dr. APJ Abdul Kalam Garu, the Missile Man of India, and the People's President, KYU Foundation is committed to nurturing scientific thinking, innovation, and youth empowerment. His dream of transforming India into a developed and self-reliant nation continues to inspire every initiative of the foundation. Through lectures, workshops, internships, industrial visits, research initiatives, and career guidance programs, KIY Foundation continues to empower thousands of students to become future innovators and responsible nation builders. STOC stands for Space, Aerospace, and Futuristic Technologies. This flagship initiative aims to ignite curiosity among students and provide them with direct interaction with India's leading scientists and technology experts. Our vision is 52 lectures, 52 speakers, 52 topics, and 52 weeks of inspiration. Every session is designed to inspire learning, innovation, and excellence. Our main topic for today is Space is the Next Destination, Explore It. And our core theme for this special Independence Day session is Building India's Self-Reliant Warfare Infrastructure. On this landmark of national pride, discussing self-reliance in defense and strategic technology is more relevant than ever. Today's session will give us key insights into how cutting-edge technologies, defense systems, and space age infrastructure are developed to make India truly self-reliant, that is Atmanirbhar. So, my dear friends, get ready to dive deep into the strategic future of innovation and nation building. Before introducing our distinguished guest speaker, let us watch a short audiovisual presentation highlighting the vision, mission, and remarkable initiatives of KIYE Foundation. I request one of our coordinators to kindly play the AV. sir. I'm Yogita Jadhav, host for today's session.
Good evening. Am I audible?
Yes, sir, you're audible. Now, thank you if the presentation inspired you and filled your heart with pride and for our nation. Don't forget to drop a rocket in the chat box. Now, I invite our student coordinator, Anjali, to briefly share her journey with KIYE Foundation. Anjali, the virtual stage is all yours.
Thank you, Yogita. Good evening, everyone. I'm Anjali Ganna, one of the student coordinator at KIYE, and I'm very happy to share a few words about my journey with KIYE Foundation. My journey with KIYE started when I joined as a volunteer for the Kalam Space Convention held at GMR Arena, Shamshabad on October 15 as part of the celebrations around the birth anniversary of Dr. APJ Abdul Kalam. Initially, I joined as a volunteer just to contribute to the event and gain some experience. But gradually, KIYE became a platform where I got the opportunity to learn, grow, and develop myself. By actively participating in various activities and events, I have improved my communication skills and leadership skills. One of the biggest changes I experienced was overcoming my stage fear. Earlier, speaking in front of an audience was challenging for me, but through the opportunities and encouragement I received at KYE, I gradually became more confident. Today, I am able to stand in front of an audience, express my thoughts clearly, and interact confidently with different people. KYE has also taught me how to approach people, build connections, communicate effectively, and convince them with the confidence. I'm truly grateful to KIYE Foundation for providing me with such opportunities and for creating an environment where students can discover their potential. My journey with KIYE is not just about volunteering, it is about personal growth, confidence, leadership, and learning. I sincerely thank KIYE Foundation, all the mentors, coordinators, and everyone who has supported and guided me throughout this journey. I hope to continue learning, contributing, and growing with KIYE in the coming years. Thank you, KIYE Foundation, for being an important part of my journey. Thank you, everyone. Jai Hind.
Thank you, Anjali, for sharing your inspiring journey and valuable experience with KIYE Foundation. We truly appreciate your thoughts. My dear friends, the moment we have been all waiting for has finally arrived. It is my immense honor and privilege to introduce our distinguished guest speaker, Dr. Nagendra Babu Samineni Garu, Managing Director at Unistring Tech Solutions PVT Ltd. Dr. Nagendra Babu Samineni Garu is a distinguished scientist, technologist, and entrepreneur. Beyond his extraordinary professional achievements, he's a trusted mentor and a strong pillar of support who has guided and supported KYE Foundation immensely throughout his journey. He holds a PhD and is an alumnus of this prestigious National Institute of Technology, NIT Warangal. Before leading UTS, Dr. Samineni spent 16 years as scientist at the Defense Research and Development Laboratory, DRDL under DRDO in Hyderabad. During his tenure at DRDO, he worked extensively on the design and complex engineering of missile systems, contributing directly to path-breaking national defense projects such as Akash Long Range Surface to Air Missile LRSAM systems. His core domain expertise covers electronic warfare, radar simulators, air defense systems, and grounded evaluation testing infrastructure. Today, as Managing Director at Unistring Tech Solutions, Dr. Samneni Garu leads efforts to design and develop indigenous electronic warfare and strategic technologies. Today, on this special Independence Day, we are truly privileged to have him with us to share his valuable knowledge, leadership journey, and insights into building India's self-reliant warfare infrastructure. Sir, on behalf of entire KIYE Foundation, we sincerely thank you for accepting our invitation and for always being a great guiding force and pillar of support for our foundation. We are truly excited to and eagerly looking forward to learning from your vast knowledge, research experience, and expertise. The virtual stage is all yours, sir.
Thank you so much. Is my screen visible to all of you?
Yes, sir, it is visible and it is audible.
Just a second. Yeah. First of all, I would like to congratulate KIYE for initiating such a wonderful activity. Uh, Knowledge sharing is always divine, and the way that you have created this platform to make the experts uh, reach the students. Okay, it's really remarkable. I appreciate whoever has thought about it, and then the entire team who is executing it meticulously. I also congratulate all the people who are attending this session in spite of it's a holiday evening, so there will be a lot of activities. In spite of all that, you guys have chosen to spend your time in learning something, which I must appreciate, and then keep this kind of attitude. It's very good that you guys are really giving your time to the valuable things. So what I would like to do is I would like to spend some time in making you familiarized with the some of the warfare technologies that are emerging today. And then, of course, the way that we should be ready, getting ready ourselves as a country. What is it that we are, working essentially in order to meet some of these challenges? Is what I will try to give some glimpses on. Then yes, I will open this session for more questions, and then I will try to answer more of your doubts so that it will be more useful for you guys. So should I go ahead?
Yes, sir, yes.
Okay, so just before going forward, a little bit on who we are. Unistring Tech Solutions is essentially a technologies company. So we are an electronic warfare company working in indigenous design and development of the solutions which are of need to the country in the domain of electronic warfare and radar. So what you see on this picture or in the slide are some of the products as a company that have been designed, developed, and then realized right from the scratch, fielded at the most critical locations. So you see one picture on the rightmost is a location which is a desert, I would say rather. The other one is at the extreme low temperatures. So, and the systems that what have been built and then have been fielded have been qualified to operate in both these conditions. So these are the challenges that when you are developing, designing the systems to meet the Indian defense requirements that one has to address. The product have to work on the extreme environmental conditions. Notwithstanding to this, we have a huge coastal area. Some of these systems even deployed at those areas. So you name any constraint with respect to the environment and weather that we have, and the products are getting deployed at all those locations. So the products have to be built to meet all these requirements. So as a company and the technologies, if you see, we work on design of digital RF hardware, software, and the full-fledged product engineering. So if you name some kind of engineering branch, whether it is mechanical, electronics, computer science, sub branches, okay, we have a team working in the company. So these are all complex technologies. In order to build these kind of products, one has to understand almost all the possible engineering branches. So um, building these products require not only mastering individual engineering branches, but also one has to balance the working across multiple engineering branches. So just on the left and the rightmost, leftmost on the bottom, what I would like to show you is the products. Some of these products that have been designed by this company have been used successfully in the operations indoor, and that's the kind of um, the opportunity any company working in the defense looks for. That means when it is needed, be there to guard the country. So this is what has been done. So we are privileged to be part of such a such a work. So just to make you aware, what are the multi-domain warfare scenarios that are emerging based on the current trends that are happening across the world. You must be seeing from the last 1.5, 2 years, most of the warfare has been largely shifted from what you or what we have experienced conventionally towards the drone and counter drone operations. You must have been seeing Russia Ukraine war, what is happening, and then you must have seen the Middle East conflict, what has happened with Iran, how they could actually control the mighty forces by using these drones. So this is one of the very critical paradigm shift in the warfare one has to understand. So then the second area is the cyber warfare. So there are huge developments, okay, that are coming up because of the advent of the AI, the kind of threats that today we have when it comes to the cyber attacks that are possible have grown are growing at the rate of 2 to 3 folds every quarter or every half a year. So that's the kind of feasibility that is there right now with the advance of AI in the cyber warfare. And space also has become the counter space also has become one of the challenging area today, because our dependency on the space is slowly started growing. Now there are areas where people are trying to target even the space assets in order to win the war. So these kind of possibilities exist. So today, threat is just not on the ground, air, water. So it has moved to the space, and then there are certain systems which can even target the space assets and then paralyze the whole communication, internet connectivity networks. So this is one of the biggest challenges. Electronic warfare has always been a war-winning scenario for most of the countries. So this continued to be again a challenging area. Measures of counter and counter measures in terms of understanding the spectrum, signal intelligence, evolving the jamming techniques, spoofing techniques. These are also rapidly growing up in the electronic warfare domain. This is another area one has to really understand. Then, of course, on the water, maritime, so the scenarios are now getting slightly shifted because there is a huge, I would say, there is a um, advancement in terms of design and development of these unmanned surface vehicles, unmanned underwater vehicles, as well as surface vehicles, which are redefining the maritime warfare also these days. And this is one area where it needs understanding and also needs the solutions to be developed in order to address these newly emerging threats. Missiles and rocket based precision strikes have always been at the center of the warfare. So, in spite of advancement of most of these technologies, whether it is drone, counter drone, or some of the cyber, still there is a dependency on firing the missiles, okay, accurately towards the targets, and then doing the required engagements. Okay, so this is still going to be continued as one of the dominant warfare scenarios, even in the future. You already have seen a lot of progress in AI, and then the way the things are getting developed by using AI, especially in the drones and then other areas, the coordinated missions which are possible, which are redefining the way that we are looking at the warfare. So this also needs to be understood. Another important aspect that has emerged in the last 1 decade is this information and hybrid warfare. How would you be able to, without fighting the war, how do you be able to achieve the purpose that what you wanted to do with any specific country is possible today, by controlling the social media, by controlling the the psychological aspects of the people, and influencing the minds of the people. the required objectives are getting achieved both politically as well as financially also. So this is something which needs to be understood, and then proper strategies to be evolved, okay, so in order to understand all these the information warfare also. So these are largely the 8 emerging multi-domain warfare scenarios that one needs to understand to be contextual and to stay in the what I would say the state of film of affairs. Okay, so now, having understood that, the threat is actually emerging like this, what kind of infrastructure one has to build as a country, and how one has to get ready themselves for the next 10 years to next 20 years in order to address these scenarios. So a very, very important thing will be persistent sensor networks today in order to respond to these kind of threats. The information, the response of the architectures of the infrastructure that one needs to develop is largely rotating around multiple sensor networks. Okay, so there is a demand for integrating multiple sensors, getting the data, crunching the data, and then analyzing this data to understand uh, the actual scenario and respond faster. So this is something very, very vital now. It is not just that I have deployed one sensor here, one sensor there for one purpose. We have been developing, deploying sensors across the border for multiple purposes, which are being used independently. So today we need to really change that scenario and then try to understand how do we integrate them. And as we understand that there are drone threats that are getting emerged, so we need to build huge counter drone infrastructure across the border. When I talk about the counter drone technologies, you will be able to understand it in more depth. We also need to build exclusive teams to understand the cyber-based threats, cyber-based defense, and we need to build the hardware, software, which will be our one needs as a country, needs to understand the possible threats, both possible on the hardware, possible on the software, and build the infrastructure which can monitor these things 24 by 7, and then keep addressing the threats that are emerging. Similarly, when it comes to electronic warfare and spectrum ops, we need to build the products which are capable of uh, intercepting the signals of the modern warfare, changing scenarios. So all that. So this is very important to build the infrastructure which is required to get these signals intercepted, monitored, the advanced signals, hopping signals, high frequency, wideband signals, spectrum. So this is very important, and build the countermeasures in order to be safe or work against these advanced electronic warfare tactics. And we also need to build now the special protection measures at the space to monitor the space assets, threats that are being posed on the space assets, build the intelligence, okay, which is targeted against these space assets, and then build the countermeasures to stop them so that your space assets are protected. This is also going to be one of the so all the sensors that are required to identify such threats, and then the counter actions that one has to do to stop them disturbing or attacking these space assets have to be built. That's another important area. So and there needs to be a very, very secured, highly reliable communication backbone that has to be built so that we are stay current. I mean, the communication doesn't get interrupted, and then we will be able to understand the threats well in time, and we will be able to manage, pass the communication, and act. So for that, more secured, reliable, persistent communication links have to be developed. So then, of course, to counter the possible missile strikes, we continue to evolve in terms of building the assets required for air and missile defense also. So this is also an area where still a lot of progress is required to be done. Long range, intercontinental ballistic missiles which can approach with multiple warheads. So first of all, mechanisms to detect them, early warning, and then mechanisms to stop them, counter them. So this infrastructure also has to be built. Similarly, for maritime and coastal security, how do we identify these unmanned surface vehicles, unmanned underwater vehicles, and then how do we counter? One is identification, then how do we counter them in order to stop posing the threats to our ships as well as the underwater submarines? Okay, so this is another area again. A lot of research is required to be done in this area, and huge infrastructure has to be built here also. And because as AI is evolving, so to stay contextual and then to stay uh, with respect to or to match the pace with which the other side is being built, and similarly in order to crunch large data and then come out with more intelligent options, we also need to build this data AI analytics platforms, and we need to build the infrastructure both in the hardware and software in order to make utilization of these this huge data crunching processes, and then build more and more intelligence to act faster. Apart from all this, one has to build the required training infrastructure in order to make the forces aware of all these threats, use the products, and then experience the scenarios which they have not seen, so that they're trained and they're ready to respond to that. Whatever equipment infrastructure that is required to enable this training, enable this equipment to be tested, has to be built. So these are all various infrastructure measures as a country, and of course all of them connected to a proper integrated command control center with the decision making capability, with a proper architecture which will give a proper situational awareness at a central level. So this kind of infrastructure now is need of the hour. It has to be built in order to address all these scenarios. Now, just coming to the possible drone threats. So today, I will spend some time in understanding what are the possible drone threats and how do you counter and measure. So in between, you guys can just hint me if I am, in the last 5 minutes, last 10 minutes, you can just remind me so that I can moderate my flow. So possible drone threats, when I say, so today we have drones that can just only come for surveillance mission, get your intelligence and go back. Then there can be drones which will come and then drop some weapons. There can be some drones, they just don't come for dropping, they do a suicidal mission. They will come and then just do the whatever is required, the way that you are seeing today in the media about the Middle East, the drones called Shahid and also they're all called kamikaze kind of things. And what we have not seen so far in most of the attacks, that whatever have happened is a really coordinated swarm attacks have not happened, but this is going to be a bigger threat when compared to one drone, two drones coming and then doing a mission, or 5, 10 of them coming one after the other doing a mission. A swarm can do a coordinated attack, which is going to be very difficult to identify and then counter. So this way also the possible. And if you look at the point 5, which is a very very big challenge for us as a country, our western border, day in and day out, we are having this problem. There are drones which will just come across the border 2-3 kilometers away from the border. They come this side, they'll just drop some payload and then go back, which are largely they drop ammunition, they drop guns, they drop narcotics, so which is big time smuggling activity. Then of course there is a threat in terms of drones carrying multiple EW payloads and then giving more EW awareness of us to whatever. I mean, the enemy can send them and then get a lot of intelligence about your radars, your communication devices, because by just getting onto airborne, you will have a lot of advantage in terms of line of sight, which will give you or which will give the enemy a more in-depth understanding of our radars as well as the communication systems. So these are all the possible ways in which the drones can be used as threats. Okay. So now, what does what do I mean by a counter drone? Or just visualize, if a drone is coming, how do I stop it? What do I do? So if you wanted to stop a drone or counter a drone, first aspect is that you should detect it. Okay. So then you will have to analyze, then action, that means neutralization phase comes. So how do I detect a drone? What are the ways in which I can say that, oh, there is a drone approaching? So in order to do that, popularly what people use is an RF detection system. Every drone, when it flies, it communicates with the ground control center. If I pick that link, I will be able to pick the drone. That is called RF detection. There are some drones, majority of them today, they don't launch or they don't work on the communication links. They are autonomous drones. So they fly by using their own navigational techniques, either GNSS, that means GPS, or there are some advanced navigational techniques. So those drones don't use any communication link to communicate with the ground. In order to detect such drones, you need radar. People also use acoustic sensors. Of course, they are very, very small range, 400, 300 meters. By using the sound of the drone, you would be able to detect a drone. And we also use UIR. So these are not primary detection devices at a longer ranges. They are the secondary surveillance devices as of now, which we will use normally to um, confirm the threat by using a visual observation. And if we want more accurate tracking of these threats and to act on them by using hard kill options, then the cameras are of very, very useful. So the first phase is to detect. And of course, you need to build a huge infrastructure to integrate all of them so that you will be able to really come out with a proper solution. Then that is where all this analysis happens. Get the data from radar, RF detector, multiple sensors, integrate it, then identify the threat. Okay, build all the analytics possible to confirm that this is the threat, and the analysis, post analysis, the command control center will be enabled with the actions that the operators can perform, whether they wanted to opt for a soft kill option or whether they wanted to opt for a hard kill option, that is in the neutralization phase. So these are the main steps in any counter drone work. So you need to first detect, then analyze, then act on it. So as when you wanted to act, as I was telling you, you have two options. One is soft kill and the other one is hard kill. In the soft kill, when you identify a drone communicating from the ground, if you disrupt that link, then the drone will lose the control and it will just go havoc. So that is what we do largely in the soft kill. People do RF jamming. We will also do all the GNSS jamming and spoofing. There are some systems which will even take over the drones. They will land at some locations. Of course, for known protocols, it is possible. For unknown protocols, it is not possible. Now, if you have a drone which is, cannot be addressed by a soft kill, that means it is going completely in the autonomous navigation mode, doesn't even use the GNSS and all. So in that case, it is not possible to stop those drones by using jamming. Then we will resort to hard kill options. There are multiple of them. We also have done a lot of work in this area. The drones can be countered by assigning a gun and firing a gun automatically. Drones can be countered by launching another interceptor drone from ground and then just send it across so that it will go against the incoming drone and it will do a suicidal mission. So we can also launch missiles. We can also launch nets in order to catch these drones and then drop them. And there is something called laser-based disruptions also. So point a laser towards the incoming drones. So these are all various measures in which you will be able to neutralize both in the soft kill as well as the hard kill measures. So this is how typically the sensors look like. A radar looks like this. An RF detector looks like this. Then you have the data fusion command control center. This is how the guns look like. This is how the jammers look like. Okay, this is how electro-optic cameras look like. And what you are seeing on the right side of this picture is a comprehensive counter swarm mechanism. That means if there are 20 drones, 30 drones, 40 drones coming from the other end, it's going to be a layered approach for the defense. First, we will apply jammers, stop some of them. Then, some drones may still pass through jammers defense and come forward. Then you launch kamikaze drones, they will do the mission. Then some drones still pass through them, then you use guns to fire and then do the last minute engagement. Okay. So this is how this whole scenario works.
In a world where threats evolve, new dangers emerge from the skies. Swarm drones, fast, unpredictable, and relentless, can overwhelm even the most secure locations. But this is where the game changes. Our advanced counter-drone system detects threats from a distance, tracking multiple targets simultaneously. Code red, incoming threats. Activated jammer. Weapons free. Kamikaze drones activated. Threats neutralized. Experience the future of security with Zen anti-drone system. For more,
So this is how typically we need to address the the drone threats. So much of sensor and then so much of hard kill mechanisms have to be worked out and then they have to be deployed.
in a world where
So this gives a now imagine if you were to do this at the border. Our border, see our western border itself is spanning more than 2,000, 2,500 kilometers. So we will have to, because these systems will not be looking more than 10 to 15 kilometer ranges. So we have to build for such a long range of the border. So hundreds of systems have to be deployed. They have to be coordinated. They have to be effectively utilized. Only then we will be able to address these kind of threats. So a lot of work is happening in this area right now. Not only for us, majority of the countries are now have understood this threat and then they started working on deploying the solutions. Now, as a user, as a student community, what is of most important for you is, or what I would like to leave you guys with the note is on. If at all any of you has some interest in this area, what should you be doing? Okay, what do what do you need to understand in order to build these kind of products? What kind of skill sets, what kinds of technologies are used? If you get an understanding of them, and if this area sounds interesting to you, and these skills can be built, these technologies can be learned, so that you will be future ready, or by the time you are coming out of your academics, you can choose the areas to work. So in order to give these guidelines, I'll be spending these next 2 to 3 minutes in this area to make you aware of what are the technologies skills that you need. For example, as I told you, these counter drone systems are the electronic warfare systems. Okay, radar is one of the main area. So if you wanted to work in the radar design, what are the areas or what kind of technologies that a typical radar building design realization needs? The first one is all about the system engineering. When I say system engineering, you need to understand what is the primary purpose of this radar. Okay, what kind of ranges that it has to look at. Okay, and what broadly underlying technology that one should use in order to build these radars is a knowledge that one has to gain in this area. So the moment if you wanted to the moment you start building a radar, so it starts with first the antennas. Okay, so the antenna and antenna array engineering is something one has to understand. That means how do I design an antenna for a specific frequency? How do I model, how do I simulate the performance of antenna? What are the important things that I need to understand about the antenna, the frequency wise, gain wise, and what is the way that I do a simulation, and what is the meaning of beam forming, what is the meaning of distributed architecture. So these are all certain things that you need to understand and then learn, okay, if you wanted to be in the antenna design. Then comes after the antenna, lot of up conversion, down conversion, filtering, noise removal, okay, amplification of the signal. All this will be in this RF and microwave design. So whatever you, if you are an electronic student, if you are studying digital, RF, electronics, these are all the areas that you need to focus on so that you can do something in the radar level design. Then the fourth important factor is, or fourth important domain is the signal processing. It is a very, very important area when you are designing either a radar or an electronic warfare system. So when you are learning signal processing, you must be having DSP1, DSP2, multiple subjects where you will be taught about the waveforms, compression techniques. You will be taught about the fast Fourier transforms, application of the Doppler, CFAR, and multiple other signal processing concepts. So you should be learning all of them. You should be learning some of the tools to design, to simulate, to model all these aspects. So then you will be contextual and you can earn a career in this area. Similarly, you also need to understand the digital hardware and FPGA based design. So this is a very, very critical and important area, whether it is a radar design or whether it is an electronic warfare system design. 60 to 70% of the work happens here, the combination of hardware and software. Okay, so some of you must be learning your VLSI 1 and 2 subjects, in which you must be using some tools to simulate various blocks and then to do synthesis to generate the RTL. So you must have been doing all that. So that stays very relevant here in this area, and that skill will get you somewhere into this domain. Then apart from that, you also these products also require a lot of embedded and control software design and development, both in the hardware as well as in the software. This is another area, okay, where you will be learning about the multiple devices, device drivers, controls, one chip to the other chip communication, hardware design, PCB design. All this happens here. Okay, so this is another area. If you build that skill again, so this is used in this design and development of the radars. Then mechanical engineering is also a very, very important area. These radars are power hungry, they generate a lot of heat, thermal management, engineering of the system, and then ensuring the system is properly housed and you are able to reduce the overall size, weight, form factor of this. And these systems have to perform a lot of travel, so you need to understand the shock, vibration, wind loads, and all other parameters that these products experience and carry out the design. So mechanical engineering also is a very important aspect. Then one has to also understand power, EMI, EMC, reliability. So these are very important while designing these systems. So if somebody, what is this? So you need to understand what kind of power management we will have to do in designing these systems. You will take 240 volts of power, and there are multiple varieties of electronics working. Some works at 12 volts, some works at 5 volts. How do you convert? How do you route the power? How do you manage this power? And how do you avoid interference of one power line from the other power line, because they're so very closely compacted. Okay, when you look at these designs, you will understand. Then, of course, integration, testing, and calibration is again a very challenging area, and a lot of work is there in this area. So For that, one has to understand how do you integrate the subsystems, what kind of signal checks that we will do at the integration level. So what kind of signal transmissions happen, what kind of alignment calibration is required, and how do one test these things in the field. This itself is again a engineering, so you will study some subjects, so you will have to learn these areas if you wanted to be in this area. Manufacturing and program execution, this is another big area. So all these products require PCB level design, PCB level manufacturing, and then PCB level assembly. And then many of the mechanical items have to be realized. Antenna realization is again a challenge. Weight optimized structures realization is again a challenge. So these are some of the areas that one has to learn. These are the technologies one has to learn. So that means if there are 8 engineering fields, every field, every engineer that comes out of an engineering college is required in order to build these kind of products. The same is the case even with the electronic warfare. Most of these points, okay, whether it is an alien system or command system, so the technologies that you require: system level engineering, wideband RF front end design, antenna design, integration test calibration, reliability, maintainability, lifecycle support, they remain same. Okay, of course, the product terminology slightly changes, but otherwise the core aspects that one has to learn is this. In this, you should ask the questions: what the tools that we have to learn? For example, if I were to be a good signal processing engineer, maybe some MATLAB aspects. If you were to be a good embedded programmer, so you need to learn, you need to be really strong at C++, learn a lot of things in that area. See, if you wanted to do something, settle in VLSI domain as a fundamental tools that you study VHDL and Verilog, this coding that you will have to learn. And if you wanted to build, let us say, a front-end GUI, because most of these products have a graphical user interface. Again, this works on Qt and then multiple other platforms of the software. So those tools that you should learn. If you wanted to be a PCB designer, again, there are some tools which are used. Okay, some arcade tools which are being relevant for this. And if you wanted to be a mechanical engineer in this area, you need to learn all the possible SolidWorks modeling tools, drawing tools, analysis tools, where you will be able to do thermal management and then structural analysis. These tools you will have to learn, so that you will get a ready-made opportunity, or you would be readily useful to the industry. So if you wanted to, any one of you wanted to set up your career in these areas, these are the areas of focus one has to build over your 4 years. And then also try to keep a kind of interest in building the hardware, understanding the hardware, and then working with the hardware, so that you will gain real experience when when you start working. So these are some of the focus areas, or the way that you should think yourself is to align. Okay, how do I, if I were to build this product, where should I start? What should I learn? Okay, and then how do I approach this problem? So if you continuously think like this, you will be getting yourself ready for the to be adopted by the industry readily. Okay. Yeah, I can take no questions. How much time that did we pass?
Thank you so much, sir, for such an insightful, powerful, and inspiring session. We will now begin the interactive question and answer session. Participants are requested to post their question in the chat box. Kindly keep your questions brief and relevant to today's topic. Sir, we have an interesting question. What inspired you to choose a career in defense research and science? Was there any specific moment or a person?
Yeah, it's a long story. When after completion of my engineering, we always wanted to work on some core technologies. Okay. So defense has always been one of the passionate, the areas of interest for me. So what happened was immediately after completion of my engineering, I got admissions into multiple IITs, and at the same time, I also got an opportunity to work with the DRDO. Then, because of the constraints at that point of time, and then the interest that also I have in the defense technologies, I joined. But what happens is during those days, DRDO used to be a kind of platform. People come, learn something, leave 2 3 years after. But I didn't do that. So the entrepreneurship was always there at the back of my mind. We have decided that we will spend some good, 5 to 10 years in DRDO, understand more on these technologies. Okay, so because building world class products like this requires a lot of exposure, a lot of problem solving, understanding the issues, correct. So we made up our mind. We have decided that no, we will build the products which are of important to the country. Those days, we were doing really good job at DRDO in terms of the missiles, indigenization of the missile systems and technologies. But when we analyzed some of the electronic warfare technologies, we were not really doing core R&D research because of the multiple reasons. The basic background that was required and all was largely at the outside, and then so not much is happening. So then we decided that there is a huge scope. Although DRDO is also building on most of these technologies, but still the pace acceleration which is needed, and there is a huge opportunity even outside. So when we have decided that we have taken this decision that we will go ahead and then build a company to work in the electronic warfare technologies. So that is how this entire process has happened. So frankly speaking, if you are also thinking that, will there be a spark, something like this just comes up and then, guides you, it never happens like that. Okay, it's all incremental. Okay, you will broadly have an interest when you start doing something incrementally. You will start, getting a lot of interest into those areas. But what happens is when you wanted to really solve a challenging problem, uh, your purpose, why do you wanted to do this, is very important. That is the one which is going to guide you. For us, it has always been building an indigenous technology. It overpowers everything, the problem, the challenge, the roadblocks that comes, it overpowers all of that. At the end of the day, it has to be a product which should be of use to users. That's the mindset that one has to have. You
Thank you,
can
sir,
go to the
for that
next
wonderful
question.
explanation. Sir, can you please stop the screen sharing?
Yes, please.
Here is another excellent question from our student coordinator, Sahasra.
Good evening, sir. I am Sahasha, a fourth year EC student. Sir, as EC students, we learn subjects like communication systems, DSP, embedded systems, FPGA, and RF separately. In an actual defense system, how are all these technologies integrated together to build a complete working system?
Yeah, it is very important for you people to understand these scenarios. Okay. See, when you wanted to build a system like this, there is always an integration that is happening. For example, antenna. So antenna does something, and antenna gives you some inputs to the next level. When I say the next level, antenna receives a signal and then it transfers this signal to the next level. So one has to decide or design specifications that, what is the output that I'm getting from the antenna, what is the frequency, power level at which I get this, what is the gain that is happening. So from this, the guy who is processing it next, let us say he is taking this signal and then let us say doing a filtering work. Okay, so he will define certain parameters that for this filter to be designed, I am expecting the signal, at these levels. Okay, and then I am expecting the signals with these, thresholds or offsets in terms of the reception of the signal. So this definition will be given. So a person who is doing this RF design should also be able to understand what possibilities exist with the antenna in terms of the gain, in terms of the transfer of the signal. So what kind of noise that gets embedded into this and then gets transmitted, only then he would be able to design this part. So when we are doing this, like this is just an example. Similarly, the same thing happens when the data transfers from RF to, let's say, digital domain. Again, they will define what is the bit rate, what is the data rate at which this comes. Okay, what is the frequency at which it comes. Okay, what is the variation that is possible. What kind of throughput that I will get it. So these definitions at each stage will happen. Okay, so and now while you are building your own expertise, for example, you are working on the signal processing domain, so you will define what is the way the signal has to come, because if you wanted to extract the frequency, you start building your own FFT blocks on top of it, floating point, fixed point. Okay, so while you are doing all this, you will also need to understand what are the limitations at which the data is coming to you, what kind of issues with which the data is coming to you, so that when you are building your algorithms, you will be able to precisely work on your algorithms, so that even the data that comes to you with kind of variations possible, you will be able to address them. So at each stage, so there will be an interface specification that is defined, and both the parties should have the knowledge. For example, if you are very good at the signal processing, if you ask me a question, sir, if I have a zero knowledge on the antenna, will it work? No, sometimes it won't work, unfortunately. Okay, so you need to have a little bit of knowledge of this also, because when you are processing this signal, what kind of pickups that the antenna has made, what is its main low power, what is its side low power, what kind of receptions that it is possible to take. Unless you have this visualization, you will not be able to do a very good signal processing work here. So while you are mastering your area, okay, getting deeper into aspects of algorithm building and then processing the signal, you will also need to have the broader domain of all the other areas, or your up as well as the down. Okay, so this is very important when you are working in the interdisciplinary systems. And whatever the tools that you have mentioned, whatever the points that you have mentioned, all they are relevant. Okay, if you wanted to work in a core domain like this, learning any of these and then getting your career in one of these areas is absolutely possible. Okay, while mastering that area, you also have to build broad knowledge in the subsequent areas also. Okay, so this is very important for you.
Thank you so much, sir.
With your permission, sir, we'll move on to the next question.
Please go ahead.
Next question will be asked by Soumya, a student coordinator from KIYE.
Good evening, sir.
Good evening.
I am Soumya, a final year EC student. My question is, how do counter drone systems detect and neutralize unauthorized drones in real time?
Okay, see, most of the drones are unauthorized drones only, whatever today. First of all, if your question is whether I should detect and then say whether it is an authorized or unauthorized drone, as of now, we do not have any such mechanisms. When I say mechanisms, if I am flying my own drone and if enemy also is flying a drone, okay, I already told you how RF detector detects a drone. RF detector detects a drone based on the signal. Okay, so what is the frequency? What is the angle at which this drone is coming? These are the two main points that I extract from the RF detector system. So that doesn't have any intelligence. Whether if this drone is running on a 2.4 gigahertz link, whether it is my drone or whether it is enemy's drone, so they may be using largely market available communication links. Okay, so distinguishing between these two is a challenge. What I can do is I can say whether this is a DJI drone, DJI Phantom drone, I can build that library. But within the DJI Phantom, whether it is my drone or whether it is unauthorized drone, I will not be able to detect. But when can we detect this? Today, government is enforcing some laws. If we are flying with the authority they are enforcing or they are asking each drone manufacturer to provide some mechanism, a chip, a transmitter, which will be able to reveal its serial number or ID or transmit some acknowledgement. Typically, it exists in the aircrafts. We call it as IFF. Okay, interrogation of friend and foe. Okay, friend or foe. So now this IAF kind of infrastructure is very huge. Those modules are heavy. They cannot go on to very small drones. So an equivalent mechanism is under design and development. If it comes, and if I am flying, okay, with authority, and based on that reception, we can build intelligence in the receivers, whether it is an authorized drone or an unauthorized drone. Okay, so then we can act on it. So technology-wise, it is possible, but this has to be enforced and enabled in these drones. Right now, it did not happen, but once it happens, we will be able to do it. Otherwise, I will be able to detect a drone, classify it, but may not be able to identify it whether it is my drone or unauthorized drone right now. So what do they do today? Today, because if I am doing my own mission, anyway, I have some intelligence information at my end. So I know that in some X direction I find, I can think of whether if my drone also is flying in that X direction, I can say, okay, I will just move out. And then if still some threat is being seen, then you can address it. So these are ways in which today people are acting on them.
Thank
Is it
you.
clear?
Yes, sir. Thank you, sir.
Yeah.
Thank you, sir, for patiently answering. Here is another excellent question from our student coordinator, Shivasai.
Good evening, sir.
Good evening.
Sir, from third year AML student. And my question is, what are the major technological challenges in developing indigenous radar system and simulators?
Okay. So, see, in design and development of radars, today, okay, I will take the example of building a radar for detecting the drones. Okay. Now, you have seen an aircraft, right? So, aircraft is very big. Okay. It gives you a very big RCS. I don't know how many of you know how radar works. So what you do is you transmit a waveform, it goes there, and then you get a reflection. You process that echo, then you declare that there is a target. This is how most of the radars work. When you have a bigger object, the other side, you will have sufficient reflections. Okay, of course, there are stealth aircraft and all, that's a different story, but 90-95% of your aircrafts are not so. So you will get a reflection because the reflection area, which we call it as RCS, is very huge. And then you will be able to process it. And they fly with very high velocities. Aircrafts just doesn't go with the small velocities. They fly 300, 400, 500 kilometers per hour, okay, and much higher speeds they will fly with. So this gives radar two advantages. One is there is a Doppler, clear Doppler that comes in, and there is a good reflection that comes in. So building a radar there is, if it is a next challenge, okay. Now building a counter drone radar is altogether a different ball game. Because you have seen drone with respect to an aircraft, if it is this much, drone is only this much. Okay. So in a layman's language, the RCS that it can generate, I mean the radar cross section that it has is very, very small. That means the reflected power that you get onto the radar of this one, I mean if a radar which you are designing it for drones is very small, that means you need to have a greater sensitivity at the receiver side in order to process. If you have a greater sensitivity, what is your challenge? Let us say side by there is a reflection coming, that also you will be receiving. So this generates a false alarm. And the speeds at which, for example, if I am talking about a radar which is used to detect the aircrafts and track the aircrafts, we will keep 40 meters per second, 30 meters per second as the threshold velocity for the Doppler. Okay. Whereas most of the drones fly between 10 to 15 meters per second, 10 to 20 meters per second. That means they fly at a very, very low velocity. You all know that they are not comparable with the aircrafts, right? So when you are flying at such a low velocity, you will have to set your, the Doppler thresholds of radar at 2 meters per second, 3 meters per second. Sometimes they also ask us to detect the hovering drones also. Okay. So now when you are working in such a narrow area, your drone flies at the same speed, and eagle also flies at the same speed. A bird also flies at the same speed. It will also give you a reflection. How do you distinguish between these two is another challenge. Okay. And then today, one is the RCS, the other one is the velocities. So they demand, a balance between your powers that you transmit versus what you receive in the receive side. And then how do you, remove these clutters? False alarms is one of the biggest challenge. Okay. So this is all at the design level. Now at the components level, if you wanted to build some of these radars today, for high power, low power, some of the devices still we are depending on the import options at the higher frequencies. These components availability also sometimes is a challenge, because as a country you all know that we don't make the devices. We do the complete indigenous design of the product, but all the ICs have to be imported. Okay, so there are certain categorically some ICs which will also impose certain challenges in terms of your design timelines, realization timelines. Okay, so of course, apart from that, you also need to do a lot of signal processing engineering today in order to master some of these areas for cost as well as the technological advantages. Okay, so if you ask me, these are all some of the challenges. Okay, when we are designing the radars today.
Thank you, sir.
Yeah.
Here is another interesting question from our student coordinator, Anjali.
Good evening, sir. I am Anjali, a final year student, and
Really?
my question is, if you could identify one gap between what students learn at UTS and what the industry actually expects, what would that gap be, and what is UTS doing to close it?
So if I were to understand your question, what is the gap that you learn at the college versus what industry looks at, right?
Yes, sir.
See, it is largely the practical gap. Okay. See, for example, you have done a VLSA course. Have you done a VLSA course?
No, sir.
Or have you done any your digital design lab? You're an electronic student.
Yes, sir.
Okay. So you must have practiced a few codes, VHDL or Verilog. You must have written, for a few blocks, you must have written some codes. Did you do anything like that?
No, sir.
Okay. So these are all certain areas of the, you must have studied a subject, but you do not know where it is getting applied. Have you attended any MATLAB session?
Yes, sir.
So what did you practice in the MATLAB session?
Like they taught us about the basics, sir.
Okay. So now they must have given you some understanding about how do you write codes for a kind of small FFT. Okay. So what is floating point? What is fixed point? So maybe some a few FIR or these kind of filters. You must have done some small codes and simulations. Okay. So now, or at some colleges that also will not be there. What happens is when you wanted to apply your theory, okay, to the designs, you also need the tools. Okay, so how do one understands these basics when you are studying a basic? If you are being taught, let us say FFT, I'm sure must have been taught across multiple disciplines. When it has been taught, you really don't know where it is being applied in the actual practical field. Okay, so this is a gap. That is one. Second thing, if somebody wants to work on the core engineering, it is all about questioning yourself. How do I do this? How do I do that? Okay, what is the start point? For example, the first question starts, where let us say somebody has to build a counter drone solution. How do I do it? Okay, I just told, we will detect an RF link. Okay, now, so when I say how do I detect an RF link? If I wanted to detect an RF link, okay, what is required? So when I say what is required, So you will say, okay, antenna is required. After that, this is required. This is required. You may have an answer, or if you type this question today, you will get an answer. Okay. So these are all the gaps when you are reading. Okay, you don't look at how do I apply these concepts for designing the systems, realizing the systems. What is the practical importance of this? So now what we have done at UTS is, okay, we have built a lot of curriculum and course modules. So now if you see, we are also promoting at our own cost. We have established now almost some 15 colleges, and we may be doing in another 20 colleges. We are sponsoring the labs, we are sponsoring the tools, we are sponsoring the teams, and they will come train you people, train your trainers there on the tools that are required for the industry. So that when you put your hands on onto those tools, you will learn something which is very, very useful for designing the products and systems there. Apart from that, we also built a large pool of training videos, course videos. Okay. So if you talk to our HR team, they will be able to share those details with you guys. Okay. Wherein you will be able to access so the information which you should learn in order to practically implement the things if you wanted to set up your career in these areas. Okay. So these are the two major exercises that we are doing in order to bridge this gap between the academics versus industry. Okay. So what you don't learn is this. So you learn a subject, you learn some concepts, and then you don't look at how do we apply these onto the practical aspects. So this is the gap that we see. And some cases we also see that so it's today nobody has to worry that okay, I am not studying in a good college, I'm not studying in a highly reputed college. So today the knowledge, learning, access is there for everybody without any bars. Okay. So all you need to do is at least start questioning yourself, because the curiosity and then questioning is the fundamental block for learning. Okay. So as long as you do that, okay, we also have, apart from all this, we also have at least 2 to 3 months of bridging training programs internally once somebody joins the company, because we understand where your learning stops. So we bridge that and then ensure that you will be given enough information, enough learning before you really start delivering the things. Okay. So these are the finer aspects of the gaps, and then how do we address them? Hope I have answered the question.
Thank you so much, sir.
Thank you, sir, for patiently answering all the questions and sharing your valuable insights. Now I invite our coordinator, Pavani, to deliver the vote of thanks. Pavani, the virtual stage is all yours.
Thank you, Yogita. Good evening, everyone. It is my great pleasure to deliver the vote of thanks for Lecture 21. I am Pavani Lasastri. First of all, I would like to sincerely thank our esteemed guest, Dr. Nagendra Babu Samineni, sir, Managing Director of Unistring Tech Solutions. Sir, thank you for your wonderful lecture today. Today's session gave us valuable knowledge about advanced technologies, bringing the gap between foundational space science, engineering, and real-world defense technology. We learned about your incredible journey of 16 years as a veteran scientist at DRDO, contributing to pioneering missile systems like the Akash, LRSAM, and now leading cutting-edge innovations at UTS. What made today's session truly valuable was the connection between theoretical knowledge and its practical implementation. It helps us understand how engineering concepts can be transformed into technologies that serve real world and national requirements. The session also showed India's commitment to self-reliance in defense engineering and technology. It reminded us that innovation, research, teamwork, and continuous learning are essential for building a technologically stronger nation. As students, your journey has given us an important message. We should not limit our learning to textbooks, but should explore, experiment, and develop solutions to real world problems. It also inspired us to appreciate hard work, dedication of our scientists and engineers in making our defense systems strong and advanced. More importantly, it encouraged us to think about how we, the next generation of engineers, can contribute to India's future technological development. So, thank you for sharing not only your technical knowledge, but also your valuable insights journey from DRDO leading to innovations UTS has motivating for all of us. I would also like to thank the KIYE Foundation for organizing S Talks Lecture 21. This program gives students a wonderful opportunity to learn from experts and gain knowledge beyond the classroom. My sincere thanks goes to the organizing committee, coordinators and technical team for their hard work and excellent arrangements in making today's lecture a success. Finally, on behalf of everyone here, I once again express my heartfelt thanks to Dr. Nagendra Babu Samineni sir and the entire Earth's family for this inspiring and informative session. Thank you all. Have a wonderful evening. Jai Hind.
As we conclude today's Independence Day a special S Talks Lecture 21, I sincerely thank our esteemed speaker, Dr. Nagendra Babu Samineni Garu, for sharing his valuable insights into building India's self-reliant warfare infrastructure and for his constant support to our foundation. A heartfelt thank you to all our participants joining us today and celebrating the spirit of innovation and independence. Stay connected with KIYE Foundation by following and subscribing to our YouTube, Instagram, LinkedIn, WhatsApp, and other social media platforms. For updates on upcoming S-Talk sessions, internships, workshops, and exciting opportunities. Let us keep learning, keep innovating, and keep contributing to a strong and self-reliant India. Thank you all for joining us. Wish you all a very happy 80th Independence Day once again. Jai Hind, Bharat Mata Ki Jai. Thank you, sir.
Thank you, Jai Hind.